Percy Lavon Julian, African-American medicinal chemist, born 1899, died 1975. A steroid chemist and entrepreneur, Percy Julian ingeniously figured out how to synthesize important medicinal compounds from abundant plant sources, making them more affordable to mass produce. In the 1930s, chemists recognized the structural similarity of a large group of natural substances to steroids. These include the sex hormones and the cortical hormones of the adrenal glands. The medicinal potential of these compounds was clear, but extracting sufficient quantities of them from animal tissue and fluids was prohibitively expensive. As with other scarce or difficult to isolate natural products, chemists were called upon to mimic nature by creating these steroids in the lab, and later by modifying them to make them safer and more effective as drugs. Chemists found their starting materials in certain plant substances that were also steroids. Percy Lavon Julian was among the many scientists, including Russell Earl Marker, Carl de Gerasi, and George Rosencrantz, who participated actively in the synthesis and large-scale production of steroids from plant compounds. Julian was born in Montgomery, Alabama, the son of a railway mail clerk and the grandson of enslaved people. In an era when African Americans faced prejudice in virtually all aspects of life, not least in the scientific world, he succeeded against the odds. Inadequately prepared by his high school, he was accepted at DePaul University in Greencastle, Indiana, as a sub-freshman, meaning that he had to take high school courses concurrently with his freshman courses. Majoring in chemistry, he graduated as valedictorian of his class in 1920. After graduation, he taught chemistry at Fisk University for 2 years before winning an Austin Fellowship to Harvard University, where he completed a master's degree in organic chemistry. After Harvard, he returned to teaching at West Virginia State College and Howard University. In 1929, Julian traveled to the University of Vienna, Austria, to begin doctoral studies on the chemistry of medicinal plants. 2 years later, with degree in hand, he and his Viennese colleague, Joseph Picot, took positions back in the United States at Howard and 2 years later moved to DePaul. There, they accomplished the first total synthesis of physostigmine, the active principle of the calabar bean, used since the end of the 19th century to treat glaucoma. Physostigmine, an alkaloid, eases the constriction of outflow channels from the eye's aqueous humor to relieve high pressure there, which, if left untreated, damages the retina and eventually causes blindness. Meanwhile, researchers in many countries were seeking innovative and cost-effective ways to synthesize steroids, including cortisone and the sex hormones. German chemists discovered that the steroid stigmasterol, which Julian had obtained as a byproduct of the physostigmine synthesis, but was also obtainable from soybeans, could be used in the synthesis of certain sex hormones, including progesterone, a female sex hormone that was important in helping pregnant women avoid miscarriages. In pursuit of this lead, in 1936, Julian wrote to the Glidden Company in Chicago requesting samples of their soybean oil. Through a series of events, he wound up being hired by Glidden instead, as their director of research in the soya division, where he set about figuring out ways to make new products from soybeans. 3 years after arriving at Glidden, Julian learned from plant workers that water had leaked into a tank of purified soybean oil and formed a solid white mass. Immediately identifying the substance as stigmasterol, he realized he had stumbled upon a method for producing large amounts of the steroid from soybeans. Though scientists already knew how to synthesize progesterone from stigmasterol, they didn't have a method for doing it on a massive scale. Now, with large quantities of stigmasterol at hand, he was able to develop an innovative industrial process for converting it to progesterone in bulk, producing 5 to 6 pounds of progesterone per day, worth thousands of dollars in those days. Soon, other sex hormones were in production. In 1948, scientists at the Mayo Clinic announced their landmark discovery of cortisone, which had remarkable effects on rheumatoid arthritis, and Julian jumped into the exciting competition to synthesize cortisone inexpensively. Cortisone is a cortical hormone of the adrenal gland. In 1949, Julian developed a new synthesis for a related substance called substance S, also present in the adrenal cortex, and differing from cortisone by only an oxygen atom. From this substance, he was able to synthesize both cortisone and hydrocortisone. Hydrocortisone and its derivatives today are more widely prescribed than cortisone products, and most industrial synthesis still begin along the same route that Julian pioneered. Julian remained at Glidden until 1954, when he founded his own company, Julian Laboratories of Franklin Park, Illinois, and Mexico City, which he eventually sold to Smith, Kline, and French. Throughout his life, he was socially active in groups seeking to advance conditions for African Americans, helping to found the Legal Defense and Educational Fund in Chicago, and serving on the boards of several other organizations and universities. Citations are in the description.